And hello! Oh, I forgot the camera. Hello! Yeah, so I don't know. So how should I start this? I watched a couple of YouTube videos of one of the people. I think he's in the C++ committee, Herb Sutter. He usually talks on CPP and stuff like that. Usually really good ideas and like good concepts and so on. And I just got the urge to make what he had made, because he has made basically here CPP from a transpiler, which if you don't know what that is, it's basically a program that converts a language to a different language, right? So while a compiler converts a language to machine code, a transpiler would be like, there's tons of them. Like TypeScript, for instance, for JavaScript, is basically a transpiler. It processes a language called TypeScript into JavaScript. Because JavaScript itself does not have types, but TypeScript adds it. And I kind of want to do the same, but like from what Herb Sutter did was like, he essentially, it's a superset of C++. So just like how C++ was a transpiler originally for C, and just a superset of C, but one of the things he has is like he has 100% interoperability between C++ and his language, because in the end it just compiles down to C++. And I thought that was really cool. And how he does you have the different macros, right? So you can write this is the line, this is this line in this file, and blah blah blah. So then when the debugger is parsing the debugging information, it will go to the correct file and so on. So I don't have to do any support for the debugger or anything. It's just there for free. You get optimizations for free. Like you get a lot of work done for you, and I feel like that would be a cool project just to learn how to make a language. I have vague concepts and so on. I did in my gymnasium. What is that in English? College? No, high school. It's the secondary education, right? In Sweden, I think Germany as well. And I made a scripted language back then and learned a lot, and it was terrible. And now I kind of want to make a proper one, but just as a transpiler. So it just converts into C++ and automate like the pipeline on how to make that to compile and so on using CMake. Thought it would be fun. I've already been writing a bunch of ideas, but I don't think we should go through these now, because that's kind of like putting the horse the cart before the horse, because things might change. But like I can go through some core things I want to accomplish, which is like the C++ interrupt, just like in CPP front or CPP2, but only keep it to like one language and one file for simplicity. So like looking at the file ending to figure out like, hey, is this my language or C++? But once like it's been converted to C++, like if I write code in C++, it should be able to easily use anything generated by the transpiler. I can show an example of that later, which is just an idea, not things that are set in stone that I'll show. Here, can you seamlessly use stuff between C++ and transpiler language? Make sure we can use C++ tooling, debuggers, etc. That's what I was talking about before. And keep the C++ mantra of only pay for what you use, right? So I want it to be a little bit more modern, but like I still want to keep the mantra of like, if you don't use it, it doesn't cost you anything. I want to do type unions like they do in Crystal. If you don't know about that language, maybe I should pull it up. All right, let's see. No, I did write an example, so I'll show that. And keep it strongly typed like C++. I do not want everything to be a template or generic. And basically keep things simple. Let's see. Where do I have the example? Right here, type unions. So all of this is still like in the air, like I haven't decided on anything, but essentially you can have that a variable in C++, right? This would be could be written as standard variant int. The difference I want, like to accomplish this, right? The difference I want is this, which should be doable, like the here, where it's like I do essentially a dispatch, You fool, never saw a product. Hello, sneeze. Yeah, you're right. But it's been like this the ADHD brain is that like it's been gnawing. Like I already have a project that I do want to stream as well, but it's nowhere ready. I don't feel comfortable showing it. But I already have that, but this has been gnawing in my brain, and I just like I just have to, right? It's compulsion at this point. And I don't expect this to be anything usable. This will just be a learning experience for me and you watching if you find this interesting. But yeah, so what we have is for a type union, I want you to be able to do this. Like, so both an int and a standard string knows how to add int to it, right? Like, I don't know if standard string actually is able to do that, but if it could, it should be able to do that. If we then have a plus hello, int does not know how to add hello to itself, so you should get a compiler error. And then what you have is essentially type reduction. This is what the crystal does. And like what you have is built in is that you reduce what the type here. Essentially at this point it can be any of these. And here to dispatch we can do the a plus 5 and it will be valid by using multiple dispatch. Which the transpiler will generate all the code for. And then here we'll do a concept of like type reduction where we say like, well, we're checking if a is standard string. So that means if this is true, that means within this if statement, we know a is a string. So then we can do a plus hello. I refuse to learn C++ again. Gonna shank anyone who tries to make me type malloc. Well, then baby, you should join me for this trip. Let's see where we end up. And then in compile time null check, for instance, this is also still like basic. This essentially makes it into a standard optional. So this would be in the standard library would look like that as a type, but it's just built in, and it means it can be a string or a null pointer. And here you do the same here. A.size compiler null pointer does not know what size. It doesn't have a size function, right? So then you do the same here again. You do reduction of the type, and now it's treated as standard string. And then I also do want something as this reduction using as. So you can use same thing here, but if you essentially you don't want to modify the because this a would shadow. Oh no, wait, I wrote that wrong. So there. Copy paste there. But like, essentially what this would do is I would create a variable here that shadows the one outside, which you might not like. You might need to still be able to refer back to a for some reason. So you can do as, like as would be conversion. Like so in this type union, it would assign A to B here. I haven't decided exactly how this should work, but yeah, this is something we should be able to do. One thing I haven't decided about is if implicit reduction, like so essentially instead of calling this conversion, I'm calling this type reduction. What I haven't decided is if implicit, because this is a thing that is pretty nice in C++, but also usually a big problem, is the implicit cast of types. And I haven't decided if you should be able to do the same with reduction or if the transpiler should stop you from that. And then to talk about like you only pay for what you use, is I've been thinking about like interfaces, essentially being able to do in C++. If you do interface, you do it as like an abstract class that only have virtual functions, right? And I want to then, which I don't like. Essentially, then you pay for even if one, you have to inherit from it in order for it to work, and two, you are paying for the virtual function cost for every even if you never refer to that type by the interface, you always pay the cost, right? So I figured I should be able to do something with the transpiler where like if you define something like this through interface, it has a I haven't decided on this interface either. Actually, let's just do this to keep the code simple. You have defined bar as a function that the interface must have. and then you define a bliss who somehow says I am implementing this interface, and then it does that or it does that. Then the generated C++ code does it by implementing the interface as a wrapper. So these classes would not be inheriting from foo. It will be a wrapper that takes a type, and then I do some magic static assert to check that whatever type is here does fully implement the interface. So here, and then it essentially by using type erasure pattern, we have an implementation that bar on foo actually calls. And there is where we have the virtual, right? So we have the implementation here being implemented. It's quite simple. And that's what, so we only pay the virtual cost if we're using an interface. So as you can see with then what we can do with Biz and Buzz, they don't inherit from it. They simply exist as their own classes, but we can then define a function, this is in the ++ code, that takes in a foo and then calls foo bar. So then we only pay that virtual cost when we're calling call bar, because it will implicitly create the interface wrapper around Biz and Buzz here. And that is essentially an example of like what kind of like thing I want to achieve. That is super far ahead though, because first things first, we need actually let me what's needed. First things first, we need a tokenizer. Convert text into a sequence of tokens, and then we need to create an abstract syntax tree out of those, which is more the logic of how the tokens. How do I describe that? Actually, I'm just gonna check Wikipedia and put that in there. AST. Actually, I'm just gonna write this abstract syntax tree. It's a data structure used in computers that represent the structure of a program or code snippet. It's a tree representative of an abstract syntactic structure. Okay, I'm gonna do a representation of syntactic structure. There we go. And then we need, I don't think we need an intermediary, and then we need essentially output C++ code, and we need to make supporting structures in C++. Like essentially, like if we're doing dispatch, that's most likely we need to generate a function that looks something this, and that takes a type and some dispatch like bar. Like we need to figure that out. That's for later. But yeah, so first things first is a tokenizer. I've already set up just a quick CMake project just to get things going, and that also has tests in it. So the first thing, actually, let me remove the camera so it's not in the way, because code is the important part. And yeah, and also all of my tests are going to be where the camera is. So the first things first, we need to have a good way to essentially write text that is this, that's supposed to be parsed by the tokenizer, and test that the tokenizer spits out the correct thing, right? So if we have here, I am gonna do. Should we do? No, should probably not be like that. how should we split this? I also tested that I could have several tests, because what I'm gonna need one thing that is interacting directly with the library, and then one thing that compiles actual C++ code and tests that the C++ code that we got out was correct. So this is Transpiler full pipeline, something like that. Full pipeline. And yeah, you're not allowed to actually use the library. We're just gonna have you empty. No. Rip. Why are you cannot open source file? Do I need to CPP C++ the configuration? All right, here. Include path here. Workspace folder. Ext. Wait. What's source? Where's include? Are you in here? No. Wait. Nope. I guess we're putting it source like that. Now you should be found, right? Include errors detected based on configuration provider. Squiggle to the setup for this translation unit. Why? Oh, there. And placeholder requires true equals true. And then we have here, you are gonna be transpiler lib, actually. No, there. Transpiler lib. There. That's what we're gonna start with. We need placeholder test. Let's just do set source. Oh, something went wrong. No, right, it's placeholder test. And oh no, I did that in the wrong place. Crap. Add executable sources. What? Cannot find source file sources. Oh, right. Can't have it easy. Oh, hello, Kavya. Kavya watched 5 consecutive streams this month and sparked a watch streak. Cool. New feature of Twitch, I guess. Congrats, I think. Well, you placeholder test there, and then we do placeholder test, blah blah blah, sources there. Tokenizer test. Tokenizer test. There, that's what we want. Did I do the same? Yeah, I did. Here we go. If you wanted it easy, you wouldn't be writing C++. Well, that's true, but I haven't even gotten to C++ yet. I'm still at CMake, which is the build system. Oh, well, not really the build system, the build automation for the build system. You can see it like whenever I'm saving these files that it's generating the build files again, and the build files end up under build here. So we have you there. So what we have is we need tokenizer. Actually, true equals true. Let's see if it builds. There. Task test. No test was found. Task. Oh. CMake refresh. Test for all projects. There we go. I wish it jumped over here by itself. Yeah, I know that one failed. Placeholder. Yeah. Wait. We only were running one test? Why? Go to source. Oh, that doesn't work. I thought I got everything there. Of course, me thinking I actually did everything right in CMake. Of course it's not correct. I mean, this doesn't work, no. So the question is, so that's placeholder. Wait, numbers are doubled. Tokenize the test, placeholder. Okay, so it's one of these. Oh! Wait, one assertion and one test case. Oh, I think... Oh, it did do both, but because they're both named placeholder, they go... Okay, I'm just gonna look at this interface then. Problems? Cannot find Transpiler test external source. Did I external? Oh, catch 2. It's the testing framework I'm using. So now, yeah, now I can find it. There. So when are you rewriting it in Rust? Never. Hello, Betsec. I think you missed my my beginning where I talked about the benefits of just doing a transpiler in C++. Because I can get all the benefits of C++ debugger and stuff like that. So I think everything there is set up. So now, essentially what we want to do now is we want to figure out a good way to store the files. So now you, when are you transpiling it to Rust? Well, I could do that, yeah. So essentially, I want to be able to like have the sources written somewhere where it's like a little bit easier. I don't want to write them inline here because that's gonna get annoying, right? So if we do Mm, 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 mm. So I think what I want a folder, what should I call it? Sources. And we do here. Essentially, the first things we can try and tokenize are just like simple initialization. And I've been thinking calling it yet another C. But I think I'll just do .trans for now, and we'll figure out later. But so from what I'm thinking as a standard, what we want is something like foo int equals 5, right? This is something we should be able to parse. So if we start only with, well, yeah, so we'll only start with that, right? And we'll do a helper that reads these sources basically. Do we want no? Eventually, I want it to be self-hosted, so it's written in the language itself. But for now, we'll just deal with the C++. Here we can make you a namespace. Something like that. Oh. And I need to figure out like from where is it running? Is it running inside build or from the root project? I think it's gonna be tests. Oh wait, standard file system. Test transpiler lib sources like that. There we go. And yeah, constant expression, so we'll do I accidentally deleted that. Something like that. Something like that. There we go. Actually, I'm gonna include like that. Sources helper .cpp. Can I? Oh, okay, it was just, yeah, okay, cool. It was just the autocomplete happened and it ran. So we have you. So first thing, correctly parses. We're not going to be doing TD like proper TDD. I'm just using test because I think that's going to be more secure or more better safety for making sure that things work as I want to. So I don't have to like constantly check for regression. There. Require that source empty. Require false, I think. Yeah, I think that's what we want. Type build. An error. Must return a value. Ooh, I forgot that. Oh, how do I capture everything? Oh, this was a while. C++ get everything in file to string. Like that. That should be it. Okay, there. Also, a bit annoying, it's not highlighting here correctly. I'm gonna see if I can fix that. Task.json. The problem master ms compile. I thought that would do it. Kind of annoying. The ms compile is not working here because it should be highlighting the error, right? It wasn't here. At least that works. But it did. Does it go to the actual to that? I don't know. Alright. We'll see if it works. And then we do task test. They're all placeholder. Do I need to refresh this every time? We make refresh test for all projects. Task test. Oh, this one. Okay, so this one failed now. Why? Sources empty. Require false. So I want this one to be false. Oh, source is empty. Oh, so something did go wrong. Okay, that's good to know. Okay. Let's... Right, so we want to step in here. There we go. So the full path we generate is... tests, transpiler lib, sources, and tokenized initialization. Let's just double check that I spelled this correctly. Yeah, that looks like I spelled it correctly. So where are we running out of? Maybe I need to set that up. CMake set working directory for test. Here we go. Can I? No. Come on, Firefox. You can do it. The directory on which the test executable will be called. If this is not set, the test will be run with the working directory set to the binary directory associated with where the test was created. The CMake current binary dir for where add test was called. Where am I supposed to set working directory? Is that like maybe add executable catch? Do we have any more arguments to this one? If we do here, I think this is the one. So we have automatic test registration. Catch, so it should be this one. Catch and discover tests. That's the one we're using. Here. There we go. Working directory. So that would be Transpiler, test, source dir, tests, Transpiler lib. So yeah, so then, that's not correct. Would be this. Cool. So then that means we should just have to do this, and we do that. Pass build. Test correctly parse initialization. That seems to work. This is a bit annoying. It says this test. Am I doing this backwards? Since I have here up anyway. Gonna be a lot of learning. Things work? Never. No, never. Never gonna work. Test cases and sections. Here we go. So we have test name tags. Okay. So I probably want to do tokenizer correctly part there. So this should work. And then we can do a section. Tokenize. I wonder how this will be read. Will get a list of 3 token. Wait, here. So it should be identifier. Oh, it's an identifier, typesetter, int, assignment. No, well, this is a identifier as well. Assignment, and then literal number or int, literal int, and end of statement. Statement delimiter, I think. So 1, 2, 3, 4, 5, 6. Probably this will change, but for now, this is what we'll do. I think section name, parse, like that, and we will do require. This is supposed to fail. Will it find it, or do I need to no test will run? The defined targets in this task are being run, are being ignored. No tests were found. Huh. Kind of annoying that it doesn't identify it to itself. A future problem to solve. There. Tokenize correctly parsed initialization failed. So essentially what it does is... Does it tell me any good information here? We'll get tokenize correctly parsed initialization. We'll get a list of 6 tokens. Tokenize the test, CPP 10, 11 failed, require false, test case, blah, blah, blah. And then it was the following test failed, tokenize the correctly parsed initialization failed. Yeah. So then we can get started. Add a per skeleton for an actual test. Sorry. And we will here add tokenizer. Sources. And we want tokenizer.cpp. Like that. And we're gonna start working here. Pragma ones, class tokenizer. Well, the tokenizer is probably static, right? So actually, so let's do namespace tokenizer. What we want it to return should be a list of tokens. So that we can do token. Struct token. For now, keeping that simple. Vector. Token parse source. I might. No, we'll just do it like this for now. something like that. And in essence, what we need to figure out the rules for this, which this is just like, this is alphanumeric. That's the rules in C++, so we should keep that. And then we have like a colon. So, and then this is also alphanumeric equals, and then a 5, yeah. It's very simple rules. So can we somehow figure out like a good way? Let's start here. Enum class type. So we have identifier type. What would you call this? Setting like typeset or like like I don't want to just write colon because colon means nothing as a token, right? Naming is hard. Typesetter. Oh, save. Remove you. Then we have an identifier again, so we don't care. We have assignment, but it's an operator. Assignment is kind of special, so we'll start like this. We might refactor this later. For now, this will be enough. Later, we're gonna do equals 5, which is, this is a type assignment, so it gets the type from here. But that's for later. So we're gonna wait with that. Literal int. It's gonna keep things simple. We're essentially only doing exactly what's in there. I might want to keep this outside, so we're gonna do because it's probably gonna grow. Oh, actually, that gives me an idea. I can, right? Wait, pragma once. Could I make this into class token type? Oh, I'm complicating things. God damn it. So this one can handle the parsing and like what kind of date. So the token will have token type. Right? Oh, I'm complicating things for myself. Right? And then we have basically a payload with each token, which is here we have foo, which is the payload. This one does not have any payload, so it will be empty. We have int. The operator is assignment. And then we have the literal. Yeah, okay. So we're gonna have And we have one variant without a payload. And then we have token. So this, and why can't I spell include? There we go. Yes, this works for me. Maybe. And then we do here, nope, here. Oh, I hear a baby that is very mad. I'm doing terrible things in code. And then we need to why can't you find that? You should be able to find it. Token.hpp. Oh well. Type. Essentially, this is every token is, right? It is a type associated with it. You can like make this simpler by just using enums and unions and stuff, but I am dumb. We might change this payload to also be, instead of an optional, we'll make it a variant, but for now this is enough. Like that. CMake list. Nope, wrong one. So we have token.cpp, and let's actually delete you. We have token.cpp, and while I'm at it, I'm gonna make a token type.cpp. Everything is an object. So now we can do include token type. Cannot open tokenizer test. Let's there. There we go. Cool. Setting up skeleton for tokenizer. So in essence, I want to make a general interface here that we can do that take text, or essentially you can ask, hey, so we need a database of tokens. Of different token types. And then you need to be able to query is the current where we're looking in the text, is that this token? So if we start with an identifier, right? Essentially we should give it a is this I haven't used this in C++20 yet. Can slice string? Can you slice strings? No, that's not what I mean. String view is just that it's constant expression, right? Let's have a look here. So we go to, is there usage examples? View good, a string, a temporary string. No, so this is not what I want. Essentially, so in the D language, you can get a range from a string, and like you'll only be looking at that. Ooh, wait, yeah, that's what I want, right? C++ ranges from string, new string from a range. Might be this thing. Since C++ 20. Use split. This kind of key. So if we have words here. Oh, this is also only compile time, isn't it? Ah, C++ is so hard to like. This is also a little bit why I want to make this experiment. Is I've just found that C++ got like, even though I have decades of experience, it's getting really hard to read, even for me. You take a view under the CC into sovereign. Okay, let's go to ranges. So I have string original, and we have a range. So can we go to views? Views here. Subrange. Combines an iterator pair into a view. Oh, that's what I want, I think. Subrange class combines together an iterator and a sentinel into a single view. The subrange is a size range whenever the final template parameter is subrange. I think this is basically what I want. Right? Because I essentially want to say, you're looking from this point. You can see my hands as I'm gesturing. There, this is important. So I want to be able to do like you are looking in the string from this point. You can't see what has happened because that's already been made into a token, and you'll be scanning ahead to find where, like, if this is a valid token for you, right? That's basically like essentially that normally would just be done in one single gigantic loop to make things work, and I'm just trying to divide it out into token type here. So we do. Oh, I also need to get client format set up. I'll do all of those boring things outside of streams. So essentially, what we want is a virtual void. How would we signal? So essentially, what we can do, we can give an optional back. That has like, hey, this part is like I think this is me, right? So that would be where are you, ranges. So we have subrange here, right? That was the thing. So we'll have a standard use subrange. Or yeah, no. So you defined in header ranges. I have you. Standard views subrange. Oh, and I need the. I need the type for the iterator, and then we have sentinel. What is sentinel? Yeah, it's just a iterator. It's just a concept, right? So if we do using scan range, Oh wait, maybe I haven't set this to C++20. Nope. So now it should be able to understand it, right? That should be it, right? So it defaults to I, and then I shouldn't have to do anything else. And then we can do like that. Scan. Right, this should allow me to essentially, in a good way, say, hey, I'm interested in this data, right? And this will output, oh, no, wait. All I need to do, I just need to return an iterator, right? Because I'm saying like, because I already have the information of like, I'm interested in this part and this. And then that becomes the payload, right? Oh, no, oh, no, right. So if the scan range iterator, maybe I should just return the payload. So if there is a like I scan. Oh no, it needs to know where it should continue up reading, right? Essentially, the problem I have is I have two cases, right? This one has no payload, and this one has no payload, right? They are just statements of like, this is happening here. The tokenizer should not have any information, like it shouldn't do like, oh, I am setting a type, so I'm gonna try and find the type next to me. What we'll do later in, I think, is in the abstract syntax tree, we'll go like, well, we expect after this for there to be a type, we got an identifier. That identifier is not a type. And like essentially that's where we actually have the structure of things, while the token list should just like the token should literally just be very dumb data. So let's see if this points to the same as the first iterator. That means it's zero letters, but it's still correct. I think that might actually work if I want to know payload, because then what we can do is we set up like token type database. Yeah, I'm just gonna keep this simple. Well, simple. I'm not really doing this simple. Database. We're gonna do something like that. Then we have no, but we do class token type there. Oh. No, I need to return the list. Oh, oh. I don't want to return a list because then I'm giving them access to add or remove or them. I want to be able to iterate over the tokens. Oh wait, no. What would be ranges library? What do we have? We have ranges. The type is a range that it is. Oh, this is just a concept. That's not what I want. The range is a view. Ranges concept views. Oh, God damn it. So all of these are concepts. So the best what I can do another subrange. But then I need to define the actual type. I just wish there was like an easy way to do iterators without having to define everything yourself. No, it wants the iterator. Alright, gonna start like this though. Here, there. There. We're just gonna implement you like that, and we'll do namespace like that, and we also need memory. Something like that. Image. Cool. So now we have this. So we'll start with identifier token type. I guess, do I need this in the include? I'm not sure. Oh, token types there. Cool. Because that becomes the question. I don't think there's gonna be any. Well, I might need it for the tests. Well, we'll just do this token types. We might move it later because I think I could probably just do. Oh no, then I just can do RTTI to test things. So I'll do this, and we have identifier token type. Oh. Token type, public token, no, token type. Public. Why? You should be able to find that. So that, okay. So we want to implement this one. I think that works. And we do override. You can find that? Right. There, and we just return null opt t for now, right? No, null opt. There. Cool. So this should compile. Unless I messed things up real badly. I did. God damn it. Let's go to token type. Oh. Nope. Subrange is not a member. I must have misunderstood this. Where are you? Subrange. Since C++20. Did I CMake list? Yeah, CMake 20. Oh! There we go. That should be it. There we go. Perfect. Sorry. So now we can. We should have. We'll do a helper function here, which is template type name type register token type, something just like that. Ooh, we might want arguments, but for now we'll just do this. The one problem with this is I can't control when this is initialized. So I am gonna do this instead, which is gonna be token type storage equals, and then we do this is incredibly not thread safe if I ever have to care about that later. There. So then we can do this, and we do auto storage equals access token type storage. So there, and then we can do that, and then we just do register token type, identifier token type, blank. So now we can register it, and this should compile. Cool. The question is, how do we access them, right? That's the, like, how do I do in a good way? Like, I mean, I can just return this as a const and let you iterate it over that way, but I kind of don't like that. I don't want you to be able to access the unique pointer either. Well, screw it. I'm just gonna do a little nice helper. Just feel safer, and then we do. Oh, I don't have any asserts, right? Something like this. Oh, here we go. And then we go with the tokenizer, parse source. And then I guess we just need to start walking through. We just need to start walking through the source, right? So, in essence, we start with, we have and then we have ranges. Now we have a ranges, sub range. Current scan is source begin source.end, right? Something like that. Will that work by itself? Oh yeah, it just figures it out, right? Cool. And we wanna walk through this until we get to the end, right? So while tokens, no, while source, no, current scan, let's have a look here. So we have begin and subrange is empty. Will it be empty if begin and end points at the same point? Checks whether subrange is empty. Either store the iterator and sentinel compare equal. Cool. So we can do while empty. While that is not true, we will keep looping. Or so we can also do. So we then do so on this current scan we will do for int token type index equals 0 as long as token type index is less than num token types type index plus plus. Oh wait. Equals, let's see, token type database, token type index. God, I'm so annoyed with my cat that it won't go away. I had it since December at this point. So now we have the token type, so we can go token type. Oh, I need it. And we scan. We give it current scan. Up to result. If result, we first test the token type scan range. No suitable use the defined definition with sub range to a token type scan. Ah, I know what's wrong. That's what's wrong, right? There we go. So now we have a result. If the result is true, then that means this is a valid type. So we can do valid type equals token type. We can break, but we also need to get the payload, right? Should I just do everything here? I kind of want to pull it out so I just don't get like more and more scopes. I was getting stuck on the small things now, which I shouldn't. What we'll do for now, essentially, what a thing I also want to do, right? I want to do here is if like an assert valid type, right? If we didn't get a valid type, that means something is wrong. Because we got something that our tokens don't, like we don't have a token for it, right? So if we do right, no, scan range iterator. So we assign that there. If that is valid, then we say we have a valid type. Assert that there's a valid type when we come out of this. And then we essentially now we need to create the payload, right? So we can do a little helper here. Oh no, that should already be included. Token type, scan range iterator. Ooh, actually, this is what we'll do. Yeah, because this should not be optional anymore, right? So we will have a token type, scan range iterator, payload iterator. And we do payload iterator equal result. There. And we can do payload iterator. Right, that's fine, right? Or what is this? If we go to, can you go there and constant iterator? You are string const iterary scary val. Iterator base. What can I assign to you? A pointer. God, reading standard memory stuff, standard library stuff is not fun. Does that work? No, we'll just have it like that. We won't test you if you're valid. We have this one here. So in essence, what we need a source for that. Actually, so what we need is the scan that iterator gives, right? So we want a standard ranges, subrange, standard string. Actually, we can just do like that. Actually, that means we do no. So we have the current scan, and we want to. No, we need to do the advancement anyway. So I think. If that is true, then we create a token with type. Otherwise, we do token type. And that needs to be a string. Right, and that creates a token. So what we can do then is tokens and place back, and we do create token valid type, and to calculate the payload iterator we do can I do does this one maybe have a way advance the iterator, right? But it will advance this one, right? Yeah, it comes to advance. Yeah, it returns myself, most likely. Return value this. Yeah, that's not what I want. I want to create a new one. So I probably want to do. Maybe I'll just do actually this. Current scan payload iterator. And we have here. And you are equal to current scan begin, and then payload iterator. Right? So if these two are equal, that means we take nothing. I think. Because that means they're empty. There. And then we want to advance current scan. Can advance take... Oh, it's the difference, right? Obtains a copy of the subrange with its iterator advanced by a given distance. Ooh, whoa. That's what I want. Right? So I think auto payload range equals current scan next right? I think this is what I want, right? A pencil server whose iterate is incremented by times, or no. Okay. So this is not what I want there. Prev is whose iterator. Okay. So this is not what we want there. Well, we can do current scan. Sorry. There we go. Current scan. Or we'll do current scan advance. Standard distance of current scan begin. And the payload iterator, right? This, yeah, pointer difference, and that's what we move forward with, right? So if we go to by given distance, do we have an example using that? No. Yeah, that hopefully that should work. We'll be able to test it hopefully. And this should be basically everything to just loop through, right? And then we just need to define the different types, right? Loop over token type in database and scan for matches. So now what we want to do is we want to take the identifier one. Ooh, the problem becomes white space, right? We kind of want to remove all white space. Do we do that first? Okay, to keep things simple and make progress, we're just gonna do this for now. We'll handle white space separately later. But now we have you, those others. So we want to identify that we are an identifier token type. So to do that, we just need to check that we're alphanumeric. Isn't there something for that? Is all num. Checks if the given character is an alphanumeric character as classified by the current C locale. In the default locale, the following characters are alphanumeric digits, uppercase letters, lowercase letters. The behavior is undefined if the value is not representable as unsigned car and is not equal to end of file. Character to classify. Is there a better variant? Oh. Let's go here. Checks if a character is classified by a locale. Checks if the given characters are classified by the given locales. Oh, but then I need to give the locale. I think we want to use it simple for now. Right? Unless lock one. Okay, okay, maybe. Ooh, this is probably something we can figure out. Future thing to solve. Or maybe I should just get going with it already. Is there like a default locale? If we go here. Remember, we have zero of type and enough as a collate. So user preferred locale setting is blah. On start, the global locale is the C locale. Replace the C++ global locale and the C locale with the user preferred locale. Locale global. Global. Oh, classic. So I can probably do include locale, and then we do classic. For now, we can change. We can change this later. There. So first it needs to be alpha and alphabetic, and then it can be numeric, right? So we need to check if to scan front, yeah. So we want to early out. So what we do first is standard is alpha, and we do u front and locale. If this is false, return, yeah. And I did something wrong. Is we have, where are you? Is it a different name? Is alpha? Oh. Is alpha. Here. Template class shorty. Standard is alpha. C lock one. Oh, it's a function. Oh, that's. I thought this would just be as like a static member, but okay. So we have here locale. So if the first one is not that, but if it is, we can start scanning. Yeah, we can start scanning. And we want all alphanumeric ones. So we want to keep iterating until it's not, right? To scan begin +1. While iterator standard is alpha, no, is num, and we do locale while. So while this iterator is alphanumeric, we will do we will increase it, and then we just return the iterator, right? So while you are that, we do not do any bound checking right now. And iterator is not okay. Wrong order. We check that you're not the end and this, then we increase you. Otherwise, yeah, that should work. So what we're gonna do is tokenize the test. Section. First token is a identifier token. Like that. And require tokens front type. Auto type. We want to check that. We'll check this by dynamic cast to actually maybe I should just do that you can ask them for string just for simplicity, actually for debuggability, right? For like when something goes wrong, we can just say like was expecting this token here and stuff like that. So I think we'll do something like this, and then for the identifier token, it's just a simple case from the string get name constant. Actually, can I reinforce this? So if we do string view, get name, and I don't know how this works. Right? So then we should be able to do something like this, right? Where we just require type get name equals identifier, right? That should work. What is failing here? Token type is not allowed. Oh. There. Cool. So now we can check that the type is identifier. This will fail though because we are not parsing the entire code, but we can do something like this: task build. Oh, errors. Nice. What are theirs? What are we missing? Unresolved external catch string maker convert. What is this? What? Convert string maker. Basic string view. Catch detail string if. Ooh. Oh, is it not liking the. If I do this. Oh. Okay. Wait, maybe. Let's do that. This is gonna take a while because I think now it's gonna recompile all of catch, which takes a little while. It might have been, since it was unresolved, it might have been the catch was being compiled with C++17 or something else. And that's why it couldn't like do the stuff with like it didn't know how to string it. It tried to use a function that was not defined. So when my source code was looking in the header, it would be C++20, but in the actual library that had been built, it's a different version. So that's why it was a missing reference. That's probably what happened here. So then we can change back to string view, I think. But first we're just going to test this so it's not something even bigger and problematic. Hopefully not. Yeah. Oh, it's the. Oh, I might have put the audio music too low. I don't know if you can actually even hear it. Or if you've just been listening to me in silence, like begrudging. Complaining about stuff. But yeah, okay, now compiled, right? So I am gonna try this again. Oh, that's wrong. There. Will it work now? Oh, yeah, okay. I was right. Okay, that was a good thing to catch. But yeah, now we have this. So I wanna start debugging here. Did it not run? Why did it not run the section? If cast. Because the test failed, right? Wait, source and wait, is the source still empty? Did I not fix this? Oh, okay. I thought I fixed that. What did I actually change now? So, all right. Why are you doing that? Can I make you somehow trigger on F5? Oop, there. We want to step in here. Full path is sources, tokenize initialization.trans. And so I'm guessing the CMake here, CMake. Where are you? Yeah, working directory. I guess that didn't work. The directory from which the test executable will be called. If this is not set, the test will run with the working directory set to the binary. Can I C++ output current no there current path. So if we do tokenize the test, actually let's do it in here. Is that a function? Yeah. Obviously, doing something wrong. We step in, and the current path is in there. That's not what I want. Maybe, okay. Maybe I need to configure it again. CMake configure. No, that shouldn't improve anything. Oh, right. So, yeah, current path is still that. So, what more? Here, let's go back. We are working directory test prefix. Specify in which to run the discovered test cases if this option is not the current binary directory is used. But I did provide it. Test prefix. Specify prefix value to the name of each discovered test case. This can be useful when the same test is being used in multiple calls to. Okay. Okay, I'm not seeing anything there. All right, so I did get some here. If there's a not set that says for the run with the working set to the binary directory. Mm, properties on tests. Can I run select and start debug configuration? So can I do here? CMake debugger. There. So this is the question, right? What does this evaluate to? Maybe, okay. So maybe I can see it if I do set test working directory and we do something like this. CMake configure with CMake debugger. Nothing. Oh, configuration already. CMake configure with CMake debugger. There. So what we have now is test working directory. So we do locales. It would be test. God, there's so much crap. It's, yeah, here. Transpiler. Test working directory. Here we go. So this works out to. Oh, I literally have the cossack here as well. That's nice. So we have ework transpiler test transpiler lib. Can I step in here? If not, no, that's set. So let's see. We do working direct. Oh, why did Xbox pop up? How do I turn this off? What? God damn it, Windows. There, Control F. Test working dir. Command. This is post build. No, test working dir. So it should work, right? Because this is right. So if add custom command in post build, we want to test target, test working dir. Okay, what if cmake cache, delete cache and reconfigure? Still at the same place. Oh, maybe that is because I'm debugging it. That's not how the test is being run. Oh, right. Yeah, because so wait, if I do task wait, cmake first test for all projects, cmake test run tests. Well, we debug error, retry. Nothing. Okay. Where did you fail? Assertion failed, valid type. Oh, okay. So then it worked. So in essence, my problem is I do not have debugger set up correctly, right? Nope, that's not what I want. Can we see here, right? So it would be build tests full pipeline. No, transpiler lib debug transpiler lib.exe, and we want to do this workspace root, and then it's test transpiler lib. I think this is what we want to do. And then we should be able to do okay. So if we go into build tests, transpiler lib debug. Did I spell anything wrong there? So we have, okay, maybe I need to add you there. So we're going to build and then tests and then transpiler lib debug, and then we have the executable, right? There we go. And now the current path looks okay. And now you're no longer false. And we can go in here. So, okay. Config errors. So there are. Right, we need to set you up first. So you're gonna be empty. What we can do is... Actually, yeah, fuck it. So just easier to see whenever you want to add a new one. This is not the prettiest. Probably want to move this somewhere else later. Let me just do this. I probably want to redo all of this. Is this going to be fine even though... No, it's not going to be fine even though it's down there. Right? It's going to complain about that. Yeah, identify not found. Now, I do kind of want to redo this a bit, and we can do that later. Now it should be fine. Yeah, we'll clean this up later. I'll do that off stream. Because I need to wrap up, but I do want to make some progress before we end. So we're gonna do F5 again, and now we can get in here. So here we're gonna parse the source, and we have... That's not right. So we go in here. Oh, right, I forgot. And then we do... God damn it. Oh, no, no, that doesn't work. Ah, no, we need to do... Yeah, I need to figure out a way nicer way to do this. So for now, token type database, we're gonna go here, and when we go to load tokens, we also access clear, and it's fine. I'm not sure, and we have to go tokenizer. No, token database. Gonna figure out a better way to do this, and I'll do that off stream. But for now, it should work. I need to have a way where it auto registers. But here, token type, database, get num tokens, and now you are 1. Perfect. So we have our current scan, and we don't have it. So we're gonna loop through this. We fetch out you, who is identifier token type, and we're gonna scan. And the first one is alpha, so it's fine. And then we start scanning. Ooh. Wait. It took the entire thing? No. So it should stop by foo. Like, or is this saying, oh, this is what's after? Oh, yeah, because it's a pointer, right? So then we step out. We have a result. The valid typing identifier. We assign the iterator there. We break. We assert. And now we want to create you. So we have the type. We have the current scan. And we have the payload iterator. And we say, we begin here and there. first is foo. So if we step in, there, the payload is invalid characters in string. Oh, there, payload, foo. Oh my god, I think it worked. Oh boy. So we create the token. We returned, and it has the type, identifier token type, payload foo. It worked. And then we want to advance our scan by this distance. And the current scan is now exactly where we want it. Oh, that's so nice. Oh my god. Oh, that is really nice and extendable. So then what I can do, just as a, we are gonna hit status. Oh wait. There we go. Hit status. Add commit. Tweaks to get shit working. Yes, I know. Amazing thing. So now that works. What I just as a quick test, because what we can easily do now is we go into here and we have type assign token type. No, not type assign. Type operator? No, type. Oh, what would the colon? What should I call the colon one? Type signifier. Token type. Type signifier token type. And then in source, we go here. We copy you. Type signifier token type. Type signifier token type. CMake list there. Type signifier token type. .cpp. Cool. I'm also gonna clean this up. There's some improvements I can do. Then we have a scan there, and this is type signifier. And essentially what we want to check is if to scan front equals colon return to scan begin, else return to scan standard null opt. Cool. So then that should just hook in by itself, right? So if we go here, we go into parts. There are no wait. I need to register it. Token type database. Register token type identifier token. Oh no. Token types. Type signifier. Type signifier token type. There we go. And we step in. We have two types of token. First one will be an identifier, and all of that is fine. And then we advance. So now we're looking at current scan is this. So the first one should fail. So here, that should null opt. Perfect, that worked. And now we got something because it said it's true. But it did not move anything, right? So if we go here. Oh, the problem is gonna be it's not gonna move it, right? So essentially now what we're gonna get is the payload range is empty. So we are gonna step in. Yeah, we just step in here, which is nice. But here, the problem is the distance this is going to return is going to be 0. Because these are, it's pointing at the same place. So we go in here. Assume that we'll do debug checking. So we return. The returned value is 0. So we do not move, which means we are just stuck here. So I think what I need to do, I need to figure out a good way to, this is gonna have to end, but I need to figure out a good way to discard the payload, so we don't do it, like a good way to signify, hey, I do not want the payload. Might be that the type knows that, and that's how I check it instead. So I still say like, hey, I'm consuming, I need to be able to say I consume these characters, and then the token type, when we going into create token, goes, I do not consume any, like I don't want the payload. That's how we're gonna do it. But yeah, that's gonna have to do it for today. Thank you everyone for joining. It's fun doing this again. And I'll see you next time. Bye!